Next time you are at a gas station, take a look at the pumps. You have got regular gasoline and diesel, but imagine trying to drive a massive jet. Neither of those fuels would do the trick for a Boeing 777. Commercial jets do not run on the gasoline we use in our cars. Instead, they run on a fuel you probably associate with antique camping stoves. It is kerosene, but wait, is gasoline not the fuel for high-performance engines? Why would a multi-million-dollar jet engine rely on the same stuff used for lamps? Welcome to Simple Things, Surprising Histories, where we explore the science behind aviation fuel. Today, we are unpacking why airplanes fly on kerosene. To understand this, we have to look back at the early days of aviation, when it all began with simple machines. Hi there! Today we're going to learn about the history of flight and early aviators. Their planes were powered by piston engines, similar to those in your car. Even today, small propeller planes still run on a refined gasoline known as avgas. But in the 1930s and 40s, aviation experienced a massive revolution with the jet engine. Jet engines do not work like car engines. They suck in air and compress it. They mix it with fuel and ignite it in a continuous flame to produce thrust. Engineers quickly realized that standard gasoline had a fatal flaw for these extreme conditions. The problem was not the engine, but the sky itself at high altitudes. As an airplane climbs to 35,000 feet, the atmospheric pressure drops dramatically. Here, physics becomes a pilot's worst enemy due to low pressure and changing temperatures. Gasoline is far more prone to evaporating and forming vapor than heavier fuels. Under these conditions, gasoline's high volatility can cause vapor bubbles in fuel systems. This leads to a dangerous condition called vapor lock, which disrupts fuel delivery. Kerosene, on the other hand, is a heavier oil with much lower vapor pressure. Even at high altitudes, kerosene remains remarkably stable and flows safely into the engine. The sky is also incredibly cold, with temperatures often plunging to minus 50 degrees Celsius. Most liquids would turn to slush, but jet fuel is engineered to stay liquid. Then, there is the question of safety and power for these massive aircraft. Gasoline is highly volatile, making any stray spark near a spill disastrous. Kerosene has a higher flash point, meaning it is much harder to accidentally ignite. Yet, when sprayed under high pressure, it burns with unbelievable heat inside the engine. Kerosene is also denser, allowing aircraft to store more energy in the same volume. For an airplane crossing an ocean, maximizing energy while saving space is everything. So the next time you look out of an airplane window, remember the humble liquid. A fuel once famous for lighting street lamps is the same marvel making travel possible. It remains stable, keeps flowing, and packs the punch needed to cross the sky. If you enjoyed this flight through history, make sure to hit that like button. Subscribe to Simple Things for more incredible stories hiding in plain sight.